Okay, day 8. What do we got? We have a grid, and we want to know the number of unique locations with an antinode and an antinode. Okay, I think. Uh, I think just like this. Nope. Uh, no, not in the middle, but away from this. How does this work? Let's see, there's like 4 things I could do. Well, okay. Why is this far away? locations. Still on. Uh, one, two, three, four, five. This is wrong for some reason. Fuck, what is the reason? Yeah, I don't want absolute values here. Shit. Still on? Okay. Any grid position. Okay. This is grid. By 50. Yeah, no points. Okay, that took me ages to debug. So what was going on here? So we're given this grid, and some of the squares of the grid, are empty. They have dots in them, and some of them are non-empty. And any pair of non-empty points. Maybe I should have just done. I mean, I probably should have done this solution for part one as well instead of trying to do something fancy. That's probably why I was so slow. Anyway, two of them can create like. Sorry, some of the points in the grid are special. We want to count how many special points there are. And a point of special, if it's in a line with 2 points that have the same character on them. Um, and in part one, uh, we have this. It's weird. Like part two has less conditions than part one. Anyway, in part one, so what are the conditions? Exactly. One of them is that it's on the line created by the 2 points. And the other condition in part one is that it's twice as far away from one of the points as the other one. So, and then in part two is the same, except we drop the condition that it has to be twice as far, which I guess in some sense is harder because you have to check more points. But actually, it's easier because you can just do what I should have done the first time and go through all the points in the grid instead of having some complicated logic to figure out what points might be special, which is faster, but it's not in the code. It doesn't matter if it's faster. Uh, okay, so does this print out the right answer to both parts? It does not. How about now? It does not. 247 and 861. Cool. Uh, okay, so what am I doing here? So we get the input. We're going to parse it as a grid, and then we're going to figure out for every type, every character, what are the squares of that type. So we can use a default dict for that. And then we say, okay, let's go through all the squares and check if they're special or not. Um, so we go through all the squares, and then to check if they're special, we go through all the pairs of points corresponding to a given, type. Um, I was a little worried, this is a lot of nested for loops here. I was a little worried it was slow, but it wasn't slow. The input's just not that big. And then we can check the conditions. So I suppose I should like clean this up. Okay, fine. So then we check the conditions. So we figure out the distance to each of the points. Let's see. I don't like using Manhattan distance. They might mean Euclidean distance. Maybe it's the same if they're on the same line. Is that true? Sounds like it's probably true. Okay, so here's the distance from our special point to the first, point of the pair and the second point of the pair. And here's the, uh, difference in rows and in columns. So to check if they're on the same line, we want to check if the slopes are the same. Uh, okay, so the slopes being the same, slopes are rise over run, or dr over dc. So this is the first slope, this is the second slope, and then we can cross multiply. So that's this check. Right, dr1 times dc2 equals dr2 times dc1. I don't want to do any division. And then for part one, we want to check if one of them is twice as far as the other one. And in part two, we don't care about that. And also, we're supposed to check if they're in bounds. They mentioned that that's important. And that's it. So we add these points to a set, although it doesn't really need to be a set because we're only iterating over every square once. And then we just calculate the sizes of both sets and print out the answer. So I spent forever on part one because I was doing some complicated thing where I was like, I started iterating over the pairs, and then I said, okay, if you know this point in the pair and you know this point in the pair, then you can figure out where the points that are, distant from them are. Which, I mean, fine, you can, but it's more complicated. Just check every point. Uh, and, you know, like I said, I was worried it was a little slow, but you can see, it's not that slow. Takes half a second. Because the grid's only 50 by 50, so, whatever. And I guess there's maybe not so many, like, pairs. Yeah, there's a lot of different digits here. If this grid was, like, all full of A's, maybe this would run too slow, but... okay, so anyway, that is it for today, and I will see you tomorrow.